Good evening, dear students. Today we will continue our discussion on hyperbola. As you know that in the previous class we discussed the first session on hyperbola, and today it will be continuation of that. Now, before I proceed further, could you please confirm that you are able to hear my voice very clearly and able to view the screen properly, dear students? Someone
Yes,
could confirm? Yeah, okay. Thank you very much. You know, dear students, that in the last class we discussed about that standard equation of an hyperbola. What was the standard equation of a hyperbola? It was x square by a square minus y square by b square equal to 1. What was that a and b? You can say that a and b in terms of that uh, the length of the transverse axis is 2a and length of the conjugate axis is 2b. Okay, so keeping this in mind, so we are going to start our next point, that is called the origin shifted form. So what is meant by the origin shifted form? When you know that as I just said that the standard equation of hyperbola is something like x square by a square minus y square by b square is equal to 1. That is the standard equation. And here the origin is at 0 0. Center is at the 0 0. What we define in case of all these conics, it's called the center. Now when we shift that center from origin to the other point, suppose at the point of alpha beta, then what we can write that equation? That equation should be written something like this: that x minus alpha by x minus alpha whole square by a square plus minus y minus beta whole square by b square equal to 1. Notice this, dear students, notice this minus sign here. That is very important. Okay. So what it says that the equation of a hyperbola with its center at alpha comma beta is x minus alpha whole square by a square minus y minus beta whole square by b square equal to 1. And here we are assuming that x equal to capital X equal to x minus alpha. If we consider that x minus alpha equal to capital X and y minus beta equal to capital Y, then we see that above equation 1 of the hyperbola reduces to capital X square by a square minus capital Y square by b square equal to 1. And with respect to this new transformation, its center is at the point 0, 0. Correct? All the other attributes, is obtained. What are the other attributes? Attributes means it's, center, then it's focus, means in fact it is foci, plural of focus, because there are two, foci. Then directrix, transverse axis, conjugate axis, length of the transverse axis, length of the conjugate axis, length of the latus rectum, and eccentricity. So all these are the different attributes of a hyperbola. So all these attributes you can obtain by replacing lowercase x by capital X and lowercase y by capital Y. Okay, in this equation. So now to know more about all these attributes, what I will suggest you is that you can look into my previous session, which is available both in the online platform at KonarClasses.com as well as in the YouTube. So now our next point of discussion, dear students, is called the parametric form and auxiliary circle. Okay. So that I'm going to take you to the next page to explain more about it, about the parametric form and auxiliary circle. So dear students, so before I discuss further, so let me show you the diagram first, and then we will discuss accordingly. So parametric form, if you remember what is meant by the parametric form, that here we define by means of a parameter. Okay, suppose P is a point, arbitrary point on that. P is an arbitrary point on this hyperbola. Now, one way we can find the coordinate of the point P is that x1, y1, that is Cartesian coordinate system. That, but in the parametric form, that we are going to express that coordinate of the point P in terms of a parameter. And what is that parameter here, dear students? That parameter here is a theta. Okay, and how we can find this thing is that if you look into this equation of a standard equation of a hyperbola, x square by a square minus y square by b square equal to 1. Think about that how you can replace x and y in terms of theta so that this equation is getting satisfied. And if you think, and you will get something like this, that x is equal to a sec theta and b is equal to uh, b tan theta. So if you write x is equal to a sec theta and y is equal to b tan theta, then dear students, what we get is that a sec theta comma b tan theta is a parametric point on that hyperbola, because it is getting satisfied by this equation as well, x square by a square minus y square by b square equal to 1, where theta is a parameter and it varies from from 0. The value of theta varies from 0 to 2 pi. Now you may have a question, sir, what is that theta? Theta is a parameter, but exactly in context to our discussion, exactly what is the geometrical significance of theta? So if you see that to understand the geometric significance of theta, what I'll tell you is that you consider this circle that is called the auxiliary circle. So auxiliary circle is what, dear students? So this is a circle, if you see, and that circle is known as the auxiliary circle. Is that the auxiliary circle of a hyperbola is a circle whose center is same as that of the hyperbola and whose diameter equals to the length of the transverse axis of the hyperbola. If you look into this hyperbola, what is the length of its transverse axis? Is 2a, and that becomes the diameter of the circle. Now, what is the center of this circle? Is at the origin 0, 0. Okay, so center of the circle and center of that hyperbola are same, and it is the origin. So then, what is the equation of this circle? So that is known as auxiliary circle. Auxiliary circle, and its equation is x square plus y square equal to a square, because a is nothing but the radius of this circle. Why? Because according to the definition of auxiliary circle, the diameter of this circle is the length of the transverse axis, which is 2a. So hence the radius is become 2a by 2, that is a. And eventually we get the equation of the auxiliary circle as x square plus y square equal to a square. Now, dear students, if you take a point P on that, so if you take any point here and that angle is theta, and the corresponding point what you get in that hyperbola is actually represented by a sec theta comma b tan theta. I hope it is clear. So and let me write it down here in details so that you can you can follow it also along with the study material what we provide. Okay, dear students. So this is about the parametric point and auxiliary circle. Okay, so any point, so let me read once more time. So any point P theta on the hyperbola x square by a square minus y square by b square equal to 1 is given by a sec theta comma b tan theta, where theta is a parameter and the value of theta varies from point to point. Here 0 less than equal to theta less than equal to 2 pi. So we get the parametric form of the hyperbola x square by a square minus y square by b square equal to 1 as x equal to a sec theta and y equal to b tan theta. An auxiliary circle, as I explained earlier, I'm just reading it out once more time. The auxiliary circle of a hyperbola is a circle whose center is same as of the hyperbola and whose diameter equals to the length of the transverse axis of the hyperbola. Thus, the equation of the auxiliary circle of the hyperbola x square by a square minus y square by b square equal to 1 is x square plus y square equal to a square. Correct, dear students? Now we move to the next topic, that is called the focal distance, and we are going to understand about that focal distance in details. Okay, dear students, so let me explain about you about the focal distance in the next page. Any point of time at any if you have any smallest clarification, never hesitate to ask me about it. So before starting discussing on that focal distance, so let me bring that relevant diagram, and after that I will explain. Okay, as you see, this is the standard representation of a standard equation of a hyperbola and its different attributes like focus, foci actually, as you see in these 2 points, then the directrices in that line nz and nz, and you see that transverse axis, conjugate axis, the center of that hyperbola, etc., and eccentricity is e. All these things. Now, what we're doing, dear students, that let's take a point P, x comma y on that hyperbola. Okay, that x square by a square minus y square by b square equal to 1. Then, as we take this point, point P having coordinate x comma y. So we know this thing, S dash P is equal to E into PM dash from the fundamental definition. From the fundamental definition of hyperbola, we know that ratio of its distance from a fixed point and a fixed line, that is a constant, and that constant is nothing but the eccentricity. So dear students, so what we see is that keeping this in mind, that we can always say that S dash P is equal to PM dash. Exactly, S dash P is equal to PM dash E into PM dash, and SP is equal to E into PM. Okay, now S dash P is equal to E into PM dash. PM dash. PM dash means what? From that point P, we draw a perpendicular to the line N dash Z dash. Okay, and what will be the that length of that perpendicular? That is actually x plus a by e. And similarly, we can find that SP is equal to E into PM. PM is equal to x minus a by e. You know what is the length of a perpendicular from a point to a straight line. Okay, if it is not, you can always go back to my straight line lectures, which is available in the online platform as well as in the YouTube. So we get these equations, and from that what we get is that S dash P is equal to Ex plus a and SP is equal to Ex minus a. So that is a very important observation. Why so? Because we see that from this information we conclude the non-negative difference between S dash P and SP is equal to 2a. That is, mod of S dash P minus SP is equal to 2a. As we see this thing, dear students, so what we can we can say is that we can make a very important conclusion that the absolute difference of the focal distances of any point on the hyperbola is equal to the length of the transverse axis. Okay, so dear students, I hope all of you agree to me on this statement what I just said, and I'm just going to write it here as well. So what is our conclusion? that the absolute difference, or conclusion is that the absolute difference of the focal distances of any point on the hyperbola is equal to the length of the transverse axis. Okay, dear students, so this is an important observation that we have taken from the focal distance. Now, keeping this in mind, so what we are going to do is that we are going to make an alternative definition of hyperbola. If you recall, dear students, we have done the similar thing for ellipse and how that alternative definition of ellipse. Now, here we are going to discuss the alternative definition of hyperbola. Now, to discuss this thing, first I want to bring this diagram in front of you, so that it will be very easy and effective way of explaining things further. So look into this two diagram, and then let me start explaining you that what is the significance of this diagram here. You see that S and S dash. Okay, let us consider these 2 points S and X dash are the 2 fixed points, dear students. So this is the point S, this is the point S dash. Here also, here is the point S and this is the point S dash. These two are fixed points. Okay, and P be a variable point, okay, which moves in a plane such that sum of its distance from these two foci, mean actually the points S and S dash, okay, is such that SP plus S dash P is equal to K, where K is a real constant. So now we can conclude two things. If the value of K is less than S dash, then we can say the locus of the point P is a hyperbola. And if we see that the value of K equal to S dash, then we can say that is the locus of the point P is union of two rays. So let me explain you this thing, dear students. So as you see, that S and S dash are the 2 fixed points, and P be a variable point, okay, which moves in a plane such that SP plus S dash P is equal to K, where K is a real constant. Now we can conclude that what we can conclude? We can conclude that if the first point is that if the value of K is less than S dash, if the value of K is less than S dash, what you can conclude? The locus of P is hyperbola. We can say is that locus of P is a hyperbola. Let me write properly. And if we get that if K is equal to S dash, if we get K is equal to S dash, this implies the locus of P is union of two rays. So we can say that locus of P is union of correct, dear students? I hope it is absolutely clear. Any doubt, please never hesitate to let me know. Now, if things are clear, then I want to discuss to the next point, and next point is about conjugate hyperbola. Okay, so now to discuss about this conjugate hyperbola, I would like to take you to the next page, next and from here I'm going to discuss. Now, one thing to pretty sure, the moment you see this statement that conjugate hyperbola, That means conjugate hyperbola is nothing but a hyperbola, but it is associated with another hyperbola. Okay. Now, let us first consider a hyperbola something like this. That x square by a square minus y square by b square is equal to 1. Okay. So what is our hyperbola under consideration? So the hyperbola under consideration is x square by a square minus y square by b square equal to 1, and we symbolically we represent that hyperbola by h1. Now we are going to construct another hyperbola h2, okay, whose transverse and conjugate axis are the conjugate and transverse axis respectively of the above hyperbola. That means what? So you see, dear students, that H1 has a transverse axis and conjugate axis. Now, what we are going to do is that we are going to construct another hyperbola whose transverse axis is going to be the conjugate axis of the hyperbola H1, and whose conjugate axis is going to be the transverse axis of the above hyperbola H1. And such a hyperbola, what we are going to construct is, we are naming it as H2. So whatever I just said in the last couple of minutes is just, let me write it down here. Okay. Apart from the last statement is in the statement, if you see that, let us now construct a hyperbola H2 whose transverse and conjugate axis are conjugate and transverse axis respectively of the above hyperbola H1. Okay, then this statement I didn't say earlier, now I'm going to say, then we get the equation of that hyperbola H2 is something like this, that x square by a square minus y square by b square is equal to minus 1. So what is the summary of this? Whatever I said is that, suppose there is a equation of a hyperbola like x square by a square minus y square by b square equal to 1 given to you, and then as it is given to us, we know what is the transverse axis and what is the conjugate axis. Now we are going to construct another hyperbola whose transverse axis is the conjugate axis of the hyperbola H1, and whose transverse axis, whose conjugate axis is the transverse axis of the hyperbola H1. It's just interchange. That means, in simple term, we can say is that the hyperbola what we are going to construct, that is H2, its transverse and conjugate axis are the conjugate and transverse axis of the hyperbola H1. Then we can say its equation should be x square by a square minus y square by b square equal to minus 1. Correct, dear students? So that will be its equation. And this H2 is known as the conjugate hyperbola. So here the hyperbola H2 is said to be the conjugate hyperbola of the H1 and vice versa. Means we can say that H1 is the conjugate of H2 as well, and H2 is conjugate of H1 and H1 is conjugate to H2. That is what is called the vice versa. Okay, now 2 points here we need to note it down. The first one, dear students, is that both the above hyperbola H1 and H2 are conjugate to each other. That though we already I already said. And the second point is that, let the eccentricities of these hyperbolas H1 and H2 are U1 and E2 respectively. Then we must get the following relationship, that is 1 by U1 square plus 1 by E2 square is equal to 1. That is a very important relationship in the conjugate hyperbola. Correct, dear students? So I hope you got a very clear idea about the conjugate hyperbola. And dear students, after this class, you can just experiment. You can in the previous class, I made a detailed derivation of the standard equation of a hyperbola. So you have the relevant knowledge. So from there, you can construct a hyperbola like x square by a square minus y square by b square equal to 1. And after that, its transverse and conjugate axis. Then you construct another hyperbola and see how it looks like, okay, geometrically. and you can also derive its equation, and it will be turning out to be x square by a square minus y square b square equal to -1. And not only that, you can find the relationship there between their eccentricities. That is, if you take e1 is the eccentricity of the first hyperbola and e2 be the eccentricity of the second hyperbola, then you can start finding the relationship, and you will land up with that relationship like 1 by e1 square plus 1 by e2 square is equal to 1. Correct, dear students? So as your understanding about the conjugate hyperbola is clear, now I move to the next point, that is called asymptotes. And I would like to first explain you what is asymptotes. Okay, asymptotes, for many of you, it is a new terminology, but let me first explain you what is meant by asymptotes. Asymptotes, dear students, is nothing but a straight line. First and foremost thing is that asymptotes is nothing but a straight line. But asymptotes to whom? Asymptotes always happen to a curve. So then what is the relationship between that straight line and the curve? That straight line is going to touch that curve at infinite. Then we can say this is an asymptotes. That means, in other way, what we can say is that asymptotes to a curve is a straight line at infinite. Is a straight line, or sorry, in a more perfect way of saying is that asymptotes to a curve is a tangent to the curve at infinity. That means what? Whatever I said, I can give you an explanation. Suppose this is a curve. This is a curve, and it goes something like this. It's straight. It's straight actually. It's not, it is not going up or down. Now, for this curve, suppose we know that equation of a curve, we can write that equation of a curve like y equal to fx. Suppose for that curve, we can have a straight line. Let me draw that straight line in the green color, blue color. So suppose the straight line is something like this. It's very near to the curve, but dear students, it is not touching it. It is going to touch at infinite. Okay, so it is infinite is a concept. So the point is that it is about to touch, but not exactly touching. Then that blue straight line, what you see, it is known as a asymptote to the curve y equal to fx, what you see in the red color, that curve. So this is known as asymptotes, dear students. So what you can say, this is known as asymptotes. So as I am discussing the asymptotes for the first time, and for many of you it is a new terminology. So first I explain what is asymptotes, and then I am going to explain that how asymptotes is coming in context to the discussion of the of the hyperbola. So dear students, so now let me explain you about how asymptotes is coming to in context to the hyperbola. So to do this thing, first let me show you this particular diagram. And dear students, whatever you see the background, there are some watermark, and that is actually this is because that I'm taking this class note. I'm taking this a picture and the relevant document from our study material, and study material all are available in the online test platform at KonarClasses.com. So dear students, what I can say is that in this asymptotes, what you see is that in the diagram, first look into the diagram. So this is the hyperbola. If you see that this is the hyperbola, if I mark it in the arrow, so this is hyperbola, dear students. Okay, and if you see, there are two straight lines I wrote. One is that y equal to b by a into x, and the other one is that y is equal to minus b by into x. So if you look into these two straight lines, so these two are actually asymptotes. So there are I already explained you about that what is the fundamental definition of asymptotes, and to different perspective I explained. So here I would like to tell you let me first write down the statement, and followed by let me explain you about this asymptotes, and then I'll come to in context to the hyperbola as well. So um, in analytical geometry, an asymptote is a curve. Sorry, in analytical geometry, an asymptote of a curve is a line such that the distance between the curve and the line approaches zero as they tend to infinite. Exactly, that is what I showed you by means of that, blue straight line and the red curve. And in context of that algebraic geometry, this is the analytical geometry concept. And in context, in some contexts, such as in algebraic geometry, an asymptote is defined is a line which is tangent to the curve at infinite. Correct? That is also I explained you. So you can, if you go through both the statement, you will find they are actually converging to the same meaning. Now, dear students, if you look into this diagram, what you observe, if you look into this diagram, dear students, that the hyperbola and two straight lines. So what we can say is that there exist two different asymptotes for the hyperbola x square by a square minus y square by b square equal to 1. Okay, so this is the equation of the hyperbola, that this equation of the hyperbola is x square by a square minus y square by b square is equal to 1. That is the equation of the hyperbola. Correct, dear students? Now, so what I'm saying is that there exist two different asymptotes for the hyperbola x square by a square minus y square by b square equal to 1. And the equation of those asymptotes are as below. One is that, as you see, that y equal to b by a into x, and other one is that y equal to minus b by a into x. So these are the two asymptotes, dear students. The equation I already showed you in the diagram. So here I'm just writing it down. Okay, so you need to remember all these things so that when you get the relevant question, so immediately you can access those information from your memory and start solving the problem what has been given. So now what I'm going to discuss now is that there are a few points I would like to tell you about the asymptotes, and here it is. First, let me bring these points, and then let me explain you further. So, my dear students, corresponding to the hyperbola, that x square by a square minus y square by b square equal to 1, there are a few points I would like to mention. The joint equation of the asymptotes, that is, one is that y equal to b by a into x, and the other one is that y is equal to minus b by a into x. The joint equation you can write is that x square by a square minus y square by b square equal to 0. Second point is that asymptotes of a hyperbola are also the asymptotes to its conjugate hyperbola. That means what? X square by a square minus y square by b square equal to 1. So it has two asymptotes, as you would see. Now it also has a conjugate hyperbola, and its equation we have seen earlier that its equation is x square by a square minus y square by b square equal to minus 1. Now that conjugate hyperbola means it is a hyperbola. So it also has two asymptotes, and those two asymptotes are the same as the asymptotes of the original hyperbola. Okay, the angle between the asymptotes is given as 2 tan inverse b by a. That is the angle between the asymptotes. Any line parallel to any of the asymptotes intersect the hyperbola at only one point. The equation of a hyperbola and its asymptotes always differ by a constant term. The equation of the hyperbola and the asymptotes means when you represent it jointly, like x square by a square minus y square by b square equal to 0. always differ by a constant term. So these are the information related to that the asymptotes. The next point, dear students, what I'm going to discuss is about the position of a point with respect to a hyperbola, and that I'm going to discuss in the next slide. So here is my point of discussion, but here it is slightly different, dear students. We already discussed that, the position of a point with respect to a circle, then ellipse, then parabola, all we discussed. But here it is, a little, let's understand first that that what is meant by that interior and exterior with respect to a hyperbola. So to explain this thing, dear students, the best way of doing this thing is to show by means of a diagram. As you see, dear students, in this diagram, this is a hyperbola that curve, any point in between. So interior is the two extreme points. So this is known as the interior point. This is also interior point, and this is known as the exterior point. So that you should note it very carefully. It is unlikely the other, curves, and most importantly, unlikely the other curves, is that its algebraic expression is completely different. So let me explain you. Then you will understand why Sari is saying like this. That first one is that. So let us consider let us consider a hyperbola x square by a square minus y square by b square equal to 1. Okay, dear students. So if you see that this is a hyperbola which we actually consider, that x square by a square minus y square by b square equal to 1. So this is the equation of our hyperbola, x square by a square minus y square by b square is equal to 1. Okay, be the equation of a hyperbola, and let us consider a point P, alpha beta, and that is an arbitrary point. That means the point either could be here, or it could be here, or it could be here. These are the three possible, relative position of that point with respect to the hyperbola. Okay, now if the point is here, dear students, then we can say the point is interior to the hyperbola. If the point is here, then we can say the point is on the hyperbola. If the point is here, then we can say the point is exterior to the hyperbola. Okay, so these are the three relative position of the point P, alpha comma beta, whose coordinates are alpha comma beta, with respect to the hyperbola x square by a square minus y square by b square equal to 1. Now, dear students, that if the exact geometric description of that hyperbola and the position of the point is given, then you no need to do any further study to conclude whether the point is inside the hyperbola, on the hyperbola, or outside the hyperbola. The point is that when you only given that equation, so you have two things at your hand. One is that equation of the hyperbola, that is x square by a square minus y square by b square equal to 1, and another one is that a point alpha comma beta. These are the two things in your hand, and from these two information you are going to decide whether the point is inside, on, or outside. So here are the conclusion. Okay, dear students, so I'm just going to write it down, followed by I'm going to explain. So the point P alpha comma beta, okay, will be known as the inside of the hyperbola. Very meaningful, inside of the hyperbola. If the value of the expression alpha square by a square minus beta square by b square minus 1 is greater than 0. Very important thing, because it is unlikely the other conics. That's why I'm saying. Okay, for example, in case of ellipse, that point should be inside the ellipse if the point means alpha comma beta, and if we take that equation of the ellipse as x square by a square plus y square by b square equal to 1, in that case it will be inside the ellipse if the value of the expression alpha square by a square plus beta square by b square minus 1 is less than 0, if you recall. But here it is different, exactly opposite. It will be inside if the value of the expression alpha square by a square minus beta square by b square minus 1 is greater than 0. It is on the hyperbola if the value of the expression is 0. Obviously, it should satisfy the equation of the curve. And it is outside the hyperbola if alpha square by a square minus beta square by b square minus 1 is less than 0. Then we can say it is outside the hyperbola. I hope it is clear, dear students, that how we can decide that position of a point with respect to the hyperbola simply by computing that algebraic expression and just deciding whether it is greater than 0, equal to 0, or less than 0. Now, dear students, the next point what I want to discuss is about the tangent to hyperbola. Okay, the tangent to the hyperbola that I'm going to discuss now, and here it is. So I'm going to discuss the tangent to the hyperbola in the next slide. So you have a fair amount of idea what is meant by tangent to a curve. I know you have a good amount of idea, but just telling you for a from the definition, and if there is any new students who will be looking into these video lectures later, is that suppose you have a curve something like this. This is your curve. Suppose this curve is y equal to fx. Now you take a point on this curve, okay, and at this point, if you draw a tangent, so that means what? Suppose a green line. This is a tangent, right, which touches the curve at a single point. Okay, so touches the curve. It may be multiple points also. That depends on the curve. So that straight line again can go and touch in the curve is is something like that. It may possible, but fundamental definition is that a tangent is nothing but a straight line which touches the curve at a point on the curve. Then we can say this is a tangent, that what you see in the green color, that is a tangent to the curve y equal to fx, suppose at the point P. This is the point, suppose. So if we say, and this is the point P, then we can say that the green line is a tangent to the curve y equal to fx, which is shown in the red color at the point P. That is known as a tangent. Now, in context to our discussion, that we have that equation of that hyperbola, that is the standard equation of the hyperbola is what? X square by a square minus y square by b square equal to 1. Correct, my dear students? So x square by a square minus y square by b square equal to 1 be the equation of a hyperbola. Now, the equation of the tangent to the hyperbola, and there will be two different types of points, dear students. The first one is that a point with coordinate x1 comma y1. In that case, dear students, so what will be the equation of the tangent? The equation of the tangent will be x1 by a square minus y1 by b square equal to 1. I repeat, dear students, if the point, that point P, having coordinates x1 comma y1 is there, and then we can find the equation of the line which is the tangent to the hyperbola x square by a square minus y square by b square equal to 1 at the point P having coordinates x1 comma y1 is x1 by a square minus y1 by b square equal to 1. That is one way of finding the equation of the tangent. Now, if the point P is a parametric point, that means what? It is a parametric point. If you recall that we discussed in the earlier in the session today about the parametric point. So at that parametric point, the equation of this tangent should be x into sec theta by a minus y into tan theta by b is equal to 1. That is at the parametric point, what is the equation of the tangent. Now, apart from these two, also we need to discuss about the what is the general equation of tangent to a hyperbola. X square by a square minus y square by b square equal to 1. What is the general equation of tangent? So, is that the general equation of a tangent is is something like this: y equal to mx, plus minus a square root of a square m square minus b square. So that is the general equation of tangent when you do not know at what point it is. Okay, you do not have a clarity on the point. If you have a clarity on the point, if a point is given on that hyperbola, then you can find the equation of the tangent to the hyperbola depending on what mode of that coordinates is given. If it is in a straightforward the Cartesian coordinate x1 comma y1, you can use this equation, that x1 by a square minus y1 by b square equal to 1. If the point is given as a parametric point, that a sec theta comma b tan theta, then you can find the equation of the tangent something like that, is that x into sec theta by a minus y into tan theta by b is equal to 1. Now, if the point is not given, but you need to have, to form that equation of a tangent, then the equation of the tangent will be something like this, that y equal to mx plus minus square root of a square m square minus b square, where the m is varying from the closed interval minus infinite to minus b by a intersection b by a to infinite. Okay, so these are the different ways of we can find the equation of a tangent to a hyperbola. Now, dear students, with this I would like to conclude the class here. In the next class, I am going to discuss about the directed circle of hyperbola, normal to a hyperbola, pair of tangents from an external point, and then we'll discuss about chord of contact, equation of chord in terms of middle point, and finally rectangular hyperbola. With this note, I would like to conclude the class here, dear students. If you have any specific question, please feel free to me. Otherwise, we'll have our class in the next session. Thank you very much.
Thank you.
Thank you.